I'm Dr. Ellen Stofan, also known as Dr. E.
And I'm Dr. Thomas Zurbuchen, also known as Dr. Z. I am so excited that we're ready to launch the next Mars mission. But before we talk about this, tell us, where are we here?
We're at the Stephen F. Udvar-Hazy Center, which is one of our 2 National Air and Space Museums. But even more than that, we're behind the scenes, socially distancing, at our Dulles Collection Facility, where we keep aircraft and spacecraft that we don't have room for out on the floor. This is one of the newest objects in our collection. It's the testbed rover that was used for the Spirit and Opportunity rovers out at the Jet Propulsion Laboratory in California. So while those rovers were on Mars, the folks at JPL could use this rover to help understand what was happening up on Mars, where they couldn't get in there and actually fix things.
I'm so excited to stand here next to this. You know, Spirit and Opportunity have really changed how we think about Mars. And you know, you look at it, it's like a golf cart size. Well, the mission we're going to launch, Perseverance, is more like a car, over 2,000 pounds, 7 feet tall, in a much more complex machine with a very different purpose, which is to prepare samples to bring back to Earth. The energy source at Perseverance is the nuclear battery, which is basically hanging from the side.
So that nuclear power source really gives you a lot more flexibility on the rover. You don't have to worry about the sand getting on top of the solar panels and diminishing the power for the rover. So bringing those samples back, that's not going to happen on this mission. That'll happen later. But this is the mission that will actually collect and cache the samples and place them so that that next future mission can come and retrieve them and bring them back to Earth. That's something we've never done before.
Oh, we've never done this before. And you know, we always want to make history in these missions, just like Curiosity has with its landing technologically, but also with its science.
I can't wait. This is going to be so exciting for all of us this summer. We got a few questions in from our audience, so here's one of them. I feel the helicopter is such a cool part of this rover I hear so little about. Can we hear some about what it will be doing and how long is it expected to operate?
The Ingenuity helicopter, as it's called, a high school student in Alabama came up with that name, and I'm really grateful for her input. Ingenuity will be the first controlled flight in another world. So what it's really designed to do is it gets dropped off the surface, it sets itself up, and then it flies a few takeoffs. First, it's just up and down. Just, you know, if you have a remote control thing somebody gives you, same thing. Just go up a foot or 2 and then down just to make sure you know how to take off and land. And then it starts flying. And then we're going to learn on the surface how we're utilizing it for future use. One of the reasons we actually want to put the helicopter there is because we're thinking, if we were there with humans, we'd really like to have scouts that really can go ahead and look at how we can get to a crater, for example, of important science, how we can get down there without having to get stuck on the way, right? Kind of to do the inch-by-inch thing. And we think that scouts like that with data from space can really be an important part, just like we use it on the ground for many applications today.
I'm really excited about it. I'm going to push you on something. Someday there will be humans going to Mars. And I would really appreciate it if they would pick up that helicopter and bring it back here to the National Air and Space Museum, because that helicopter covers everything that we talk about here. So someday.
I think that's exactly the right thing. Here's the next question. How could Perseverance help us potentially for the future human exploration of the red planet?
You know, in a number of ways, from the science it's gathering to an actual experiment on board. First of all, we have an instrument on board called MOXIE that's actually pulling carbon dioxide out of the atmosphere and splitting out oxygen. Oxygen is important because obviously it's something we need as humans to breathe, but it's actually also a component in rocket fuel. And if we're going to have any kind of sustained human presence on Mars, we're going to have to learn to live off the land.
Yeah, there's some things that, you know, just really see the ingenuity of the scientists and the engineers. The calibration target for Sherlock, one of the instruments, actually has specific materials that are of huge importance to human explorations. There's 3 samples of astronaut suit materials there. We learn how these materials interact in the Martian atmosphere. So how cool is that?
That's really cool, because here with our spacesuit collection that we have here at the Air and Space Museum, you can really tell the Apollo astronauts that walked around on the moon, because their suits are covered with a very fine glassy lunar soil.
Thanks so much for this discussion. What an amazing story we're in the making here. And also for doing this in this environment, full of stories, full of secrets in a place I've never been before. And I can't wait to come back for another episode of
Easy Science.